So first step to a two-column proof is to state the given. It's telling me that angle 1 and angle 2 are congruent. We're trying to prove that all of these are congruent. If angle 1 and angle 2 are congruent, then all of these are congruent. So if that guy and that guy are congruent, then they're all congruent, but we have to get there using some justifications. What else do we know that hasn't yet been stated that will lead us to the proof? Look at the figure. What else do we know? Think back in geometry.
They're all right angles.
Maybe. We don't know that for sure. There's nothing that indicates it. Notice the figure. There was certain. There was a certain theorem that we learned given this sort of figure. We know angle 1 is congruent to angle 2. Is angle 1 congruent to any other angle? Is angle 2 congruent to any other angle? Is there a relationship between angle 3 and angle 4? What do you guys think? Yeah, why? We don't know that for sure. But good try.
It says in the, like...
That's our answer. That's what we're trying to get to. Okay? It gives us that angle 1 and angle 2 are congruent. We need to say that angle 1 is congruent to angle 3 and angle 1 is congruent to angle 4, right? And then all of these will be congruent. Okay? They're across from each other, yes. What's that called?
I forget the word.
Can anybody help? So like angle 1 and angle 3? Nah. Starts with a V. Vertical angles theorem. The vertical angles theorem says that angle 1 and angle 3 are congruent. Hey guys, just like in algebra, when you had like a 2x plus 3 equals 11 or something, and you realize that you're just going to subtract over that 3 every time, right? You realize it's going to work pretty much the same way every time. The numbers just might be different. You guys started to realize that after doing some practice, right? It's the same idea here. Anytime you see a figure like this, where the two lines cross, you're going to end up using the vertical angles theorem. Okay, I almost guarantee it. Alright, so let's look at what we got. We have angle 1 is congruent to angle 2. We have angle 1 that's congruent to angle 3. What else do we know? Angle 2 is congruent to what? Okay, so that's going to be true for the same reason, right? They're across from each other. Before I write that one down, just because it's going to flow a little bit awkward if I don't do it this way. Angle 1 and angle 2 are congruent. Angle 1 and angle 3 are congruent. 2 and 3 are congruent. Based on what property? Do you guys remember? Oh gosh, it's been like a week for you guys. We just learned this. It's the transitive property. The transitive property will show up all the time. The sooner we can embed that in our brains, the better. And do you guys understand it? So it's like, whoops. If angle 1 is congruent to angle 2, so let's say it's like 30. If angle 1 is 30 and angle 2 is 30, and angle 1 is 30, so angle 3 is 30, then I know that angle 1 or angle 2 is 30 and angle 3 are 30. They're all going to be the same. That's the transitive property. Okay, now let's back up and the other vertical angle, right? Angle 2 and angle 4, they're vertical. So we can say that. So we have all these congruent now. We have 1 to 2, that was given. 1 to 3, that's vertical. Do we have 1 to 4 yet? Not yet. We have 2 to 1. We have 2 to 3. We have 2 to 4. Do we have 2 to 3 yet? Yeah, we have that. Okay, we have 3 to 1, 3 to 2. Do we have 3 to 4? No. But if angle 2 is congruent to angle 3 and angle 2 is congruent to angle 4, what do I know? By what property? Transitive property. We're still missing that angle 1 to angle 4, aren't we? Still not listed anywhere in there. But if we look back, we can pick out a transitive property here. Let's say if angle 1 is congruent to angle 3, and angle 3 is congruent to angle 4, do you see how I can say angle 1 is congruent to angle 4 now?
Yeah.
They have to be the same, right? So again, that's a transitive property. Whoops. Right over.
You've done that with angle 2.
Yeah, you could have. There's a couple different paths there. Okay, for some reason it's writing over itself, so let me see if I can fix this. Anyway, we have it then, right? We have angle 1 congruent to angle 2, congruent to angle 3, congruent to angle 4, and everything in between. So that's our takeaway. Page 132 is what we're doing. Go ahead and get out a blank sheet of paper. We'll do the assignment, as much of it as we can here in class. All right, here it is, page 132, 2 to 4. Number 2, what is the value of x? What we got going on there? How do we figure that out?
Wish I cared.
If you don't put it equal.
Yeah, set them equal to each other.
You look like a little.
So we'll have 6x, let's focus, 6x plus 16 equals 136. Set them equal to each other. And then solve. So I'll subtract over 16, I'll have 120, and x will equal 20. Value of x is 20. There we go. Make sure you answer the question and read it carefully. Your friend knows, number 4, your friend knows that angle 1, your friend knows that angle 1 and angle 2 are complementary. So that's angle 2 here. Your friend knows that angle 1 and angle 2 are complementary. He knows that angle 1 and angle 3 are complementary. He concludes that 2 and 3 are complementary. What is the error in his reasoning? So this is the congruent complements theorem. You have to be real careful here. The transitive property doesn't really work when you're talking about complements and supplements. So let's just pick out an example. Your friend knows that angle 1 and angle 2 are complementary. What does that mean? What's complementary mean, guys? They add up to 90. So let's just say, for example, if angle 1 is 60 and angle 2 is 30, would they be complementary? Yeah, they would. So angle 1 and angle 3 are complementary. So angle 1 we already know is 60. Angle 3, if they're complementary, what does angle 3 have to be?
30.
got to be 30. So now the question is, here's the error. He concludes that angle 2 and angle 3 are complementary. Are angle 2 and angle 3, are they complementary? What are they?
30.
They add up to 60.
They're the same, right? They're congruent. So the theorem says if two angles are complementary to the same angle, they are congruent. It's called the congruent complements theorem. There's an example. If two angles are complementary to the same angle, so 2 and 3 are complementary to angle 1, then angle 2 and angle 3 are congruent. So what's the error in his reasoning? They're not complementary, they're congruent. They start with the same letter. They don't mean the same thing. Questions or repeats before we move on?
Yeah.
COMP period.
Wait. Say number 4 again. They're not complementary.
Yeah, they're not complementary, they're congruent.
He wants to know how to
I
spell
got it.
it.
I got it.
Sound it out, Devin, if you really want to know
I
that.
did.
bad.
I got it.
Oh, come on.
So aggressive.
So can you just put on for the congruent, so I spell it out?
Yeah, this is not showing up there. Number 6, what do we know about 3x and x, 80 minus x? What do we know about those two values? What do we know about 3x and 80 minus x?
That word again. Complementary? No. Vertical.
They're vertical. They are congruent. The vertical angles theorem says vertical angles are congruent. So congruent meaning equal, you can set them equal to each other, okay, the same length. So you can set them equal to each other. And then solve. From here I'm going to add over x, gather my like terms across the equal sign, which means I have to use operational inverses, the opposite, to get it across. And it wants you to find the value of each variable, so there I did. I found the value of x. Why don't you guys try number 8 on your own, and I'll set up number 10.
Yeah, where did that come from?
Oh, it says 76.
No, we're doing 8.
You might as well just do 7 if you're in the middle of it. Because on number 10, you're up to do number 7 on number 10.
I can barely even see because of the light.
A little bright, huh?
Thank you.
Wait, so number 10 is 70?
Yeah, so on number 8, let's see, what do we do? I would subtract over x, gather my like terms across the equal sign. You have 90 equals 3x. What'd you get for x, guys? 30, good. Which answers the question, we just have to find the value of the variables. Number 10, it wants you to find these angles. It wants you to find like that angle and that angle and that angle. Okay, it wants you to find all those angles. In order to do that, you have to look back on number 7, exercise 7. Figure out what the value of x is. That might help us here. But let's look at something. On number 7, what's the value of this angle right here? 76, right? the value of this angle right there? It's got to be 76, right? Because they are congruent because of the it's a vertical angle. This angle right here on top, what does it have to be? Not going to be 76, is it?
No.
So they are adjacent and they make up a line, what we call a linear pair. Linear pairs add up to what? 180. Linear pairs are supplementary. So if 76 of the 180 is right here, then how much of it's left over to put right there? You said it. There you go. It's 104, which means on the bottom it is 104. So you can answer it just like I did here with the X and filling in the angle measures. So if we know a little bit, we know a lot. I tend to say that here in geometry. You can know a little bit and still know a lot based on these figures. Number 12, developing a proof. Complete the following proof. All right, we know that angle 1 and angle 3 are given. Circled them there. We're trying to prove that angle 6 and angle 4 are congruent. So it gives us the answer. We just have to somehow get there. So they start the two-column proof for you. That angle 1 is congruent to angle 3. That's given. Then it says angle 3 is congruent to angle 6. Why? They're vertical. Didn't I say I was going to show up a lot? Shows up all the time. So vertical angles theorem. Next, it uses the transitive property. So let's look back and see if we can see the flow, the pattern. Angle 1 is congruent to angle 3. Angle 3 is congruent to angle 6. Therefore, angle 1 is congruent to angle 6. So yeah, angle 1 is congruent to angle 6. Yeah, my iPad's being goofy again. Oh, did it finally show up? There we go. Okay, so 14 we got, what was it, 55?
Yeah.
And then 16, you just had to set those equal, guys, so I'm assuming you can do algebra. The idea is to set them equal. And just to double check your answer, should be 15, I think. Yeah, sounds about right. Number 18 then, measure of ABC plus XYZ is 180. ABC and XYZ are the same. Then ABC and XYZ are right angles. Explain why this statement is true. All right. If they are going to be the same thing, so let's just call them X. We don't know what they are, but they're the same. And you're going to say they add up to 180, right? So you can just follow me along here as your explanation here. If they're the same and they add up to 180, what's X plus X? 2X, right? So that means x equals 90. If they're the same and they add up to 180, that means they're right angles. Is 90 a right angle?
Yeah.
Uh-huh. So there's your explanation.
Are you sure about that?
Be positive.
Yeah, I am sure.
We don't write it because it's right angle, we just write like what you saw.
Yeah. All right, next page.
Mikey's. Look how soft on him. I think he looks good. There's more. Like they're bad. Those still his birthday.
Okay.
When was your birthday? First day of spring.
First day of spring, gives you the most random answer. What?
I don't
Do you happen to know the first day of spring?
Actually, it's like different every year. But usually it's
All right, in the game of miniature golf, golf bounces off the wall at the same angle that it hit the wall.
It's something of March.
it's a month before it's one.
In the diagram, the ball hits the wall at 40 degrees. Hits the wall at 40 degrees. Use theorem 2-3. What are the values of x and y? If that's 40, that's a 90 degree indicator there. What's x? 50. Yeah, how'd you get 50? 90 minus 40. Yeah, if that's 90, it makes a linear pair. It means that's 90. 40 of it's there. It means 50 of it is there. What's y? X is 50 and y is 50. (22) Name two pairs of congruent angles in each figure. Two pairs. So 22. Yeah, we have one indicated here, right? KPJ is congruent to MPJ. We know that because of the indicator. It's a little bit hard to see, but it is there. Right there, there's an indicator there. So if they're congruent, what else do we know?
LPM or MPM.
Let's start there. LPM. LPM is congruent to what other angle then?
LPK.
LPK. Good job.
Wait,
Oh my
what was
gosh,
the,
I
what's
wasn't
that
done.
angle?
Whoops.
LPM is congruent to LPK.
Wow.
Did you have this concept?
LPM.
Yeah, for real. Like, have my
That
parents.
might use 2 seconds.
I'm trying to learn that. Spotlight.
All right, 24 in the photograph, the legs of the table are constructed so that angle 1 is congruent to angle 2. Okay, cool. What is the theorem that you can use to justify the statement that angle 3 is congruent to angle 4? That is the... So 1 and 3 and 2 and 4, they're going to be supplementary, right? They make a linear pair. So if they're both congruent and they're supplementary, that is the congruent supplements theorem.
What's the first few letters of theorem?
I do THM theorem.
Okay.
26, last one we'll have time for, probably. These questions are always, they're like brain busters here.
No.
Oh, kind of blurry. A is twice as large as its supplement B.
That's this, oh, never mind.
A is. So that's your A equals. A is twice as large. So that's 2 times B. What do I know about A and B? They're supplementary, right? That word supplement. So they add up to equal what? 180. If A equals 2B, I can use a substitution here. Instead of writing A, I'm going to write 2B plus B equals 180. Can you solve that for B?
Yeah.
Yeah? Go ahead and do that, and you'll be able to do 26. And the rest of them are pretty much a review, so you'll have them to do on your own. So you're going to 40. You only have a few more to do.